Good morning, everyone. So let's continue and finish our terrain exercise from last class. Just to make sure we are in the right place, I do want to ask you, if you have not yet, I do want to ask you to launch that 08 terrain project. That was the one that we were working last time. And if for some reason your script is not pulled up, you can come on the Files tab, go on Code, and click on that partial code. Hopefully, you don't have anything in your environment. If you have closed your RStudio since last time that we met. And if that is the case, we stopped here doing the, let's see, we stopped at the elevation map, I believe, last time. So if you come here on the outline and you navigate to the aspect, which is the next thing we want to calculate here. If you come to that chunk and you click the run all above, I think it should work for it to create all the objects we need. We can see the progress bar here as it is going through the different chunks. If you left any code with error above, then this approach does not work because it will stop at the chunk that finds an error. In my case, it was able to run properly all the way through slope. I see the objects are up there. Another way you can check to see if you didn't have any errors is if you look on your console. If you have errors, if an error happened, you would have stopped at that chunk and you would see the last thing you would see here would be an error message. That is not the case, at least not on my side. But if that's the case for you, you can see where the where the error happened, go back to the chunk, fix it, and then keep running. All right, so just a quick recap here. What we did was to bring the elevation data for this field. Again, elevation was collected with some type of equipment that had a GPS on board. And so it was taking the X and the Y coordinates, and grid code here is the height in feet. So we did a processing here where we clean names, we renamed the grid code to elevation in feet. So now that variable name is more informative. Just increase my font here. Then transform that to meters. We kept only elevation meters, point X and point Y. We used the function STSSF to transform this data frame into an SF object. So a quick recap here. There is a distinction between what the file is in your system and what the object is in R. So this file here was a CSV. CSVs are not geospatial data sets, even though it has columns for it, point X and point Y, but CSV itself is not a geospatial data, or it's not a geospatial file type. So we bring it, that CSV, that is interpreted as a data frame in R. We do some wrangling. We use the function STSSF to transform this from a data frame to an SF object, which is a geospatial vector data. Because it does not have a CRS, we use STSetCRS to determine the native CRS. So remember, this should always be the native, not the one you intended to be. So the native here was WGS84. This is the EPSG for that. And then we use ST-transform to finally change that CRS to what we want, which is in meters rather than degrees. So we changed that to UTM NAD83 with this. So that's the processing we did. We made some plots to explore this. We brought in the boundary. We made a grid as raster. Remember, when we are interpolating, we need a grid as raster. So the cells are raster cells. So we use that grid to then interpolate, in this case, using inverse distance weighted. We're just interpolating elevation meters. Interpolation happens in two steps. The first one is you set the formula where you give the data set and what column of that data set you want to interpolate. The second step is to predict, where you give that the formula that you created above and you give the grid that we created, Remember, every time you're doing interpolation, you're basically doing a prediction of what would be the value in each one of those cells given the underlying data points. So that's why we always need to give a grid when we're interpolating. Then we made a map of elevation. And then with elevation is the primary variable that we then use to calculate secondary variables. In our case here, we have already done that we have already done it for slope. To do that, really, this is the main part that does it, or really this function here, the terrain function, where we ask what we want to calculate out of the elevation data. So here we were asking for the slope. To get here, we just did some wrangling to select some columns. This terrain function only accepts objects of type spat raster, which come from that Terra package. So we first have to transform our stars object to spat raster, which this is doing. Then we can plug that into the terrain function, get slope. But I do like working with stars because it's easier to plot in ggplot. So we transform it back to stars and then just calculate slope as percent and just keep that. So I hope that as we, and this is not just for this script, but really for every script we do, I do hope that you are also creating this understanding of what each lines of code are doing, because they're there for a reason. And that, even though I'm telling you what we're doing, we're not really searching for what should I do next. But I do hope that you're getting this understanding of what each one of these steps here are doing in our workflow. And then we just made a slope map. So we see here that slope is varying from about 1 to 7% on this field. We have lower slopes on the dark areas, and we have higher slopes on the, I guess, yellow and gray areas of this map. So greater slopes here. We also talked about the fact that we have more NAs on the slope than we did on the elevation. And again, the reason for that is the way that these algorithms work to calculate slope, aspect, and other things is imagine that you're sitting in one of these raster cells and you're looking to your neighboring cells to determine what is the slope, what is the aspect. And so because of that, when those cells that you are sitting on are on the border or near the border of the field, they may not have one of those neighbors. And by default, when it doesn't have all 4 neighbors, it gives you an NA by default on that cell that you're sitting on. All right, so our next step here is to calculate aspect. So aspect is just a variable that allows us to understand where that cell is facing in relation to just its slope that was based on the elevation. So aspect is just going to give us an understanding of where is the slope, because right now we know the slope, but we don't know which way it is facing. So aspect is going to help us with that information. So here, if you come to that code, we're going to start developing now the code for calculating aspect of this field. We left you most of the code here, so we're starting with the inverse distance weighted prediction of elevation, which is, if you run it, it's going to be a stars object. So it is a raster. Remember, we need that to calculate these secondary variables. I'm just renaming here that var1 pred to elevation meters, transforming this to a spat rast object. So if I run up until here, just so you see, this now is a spat raster because, again, that's what's needed by Terra package and the function we're going to use next to calculate aspect. So what we're going to do now is I just left you 3 dots there. This is the main difference between what we did on slope and now we're changing for raster or for aspect. These 3 dots are the only difference between the codes. So that's why I left you everything else except that. So go ahead and delete those 3 dots. We use, again, the function terrain from package Terra. So I just want to make sure I'm getting that function from this package. So we use this notation here of package name, : and then the function. The name of the function is terrain, as we saw above. the first argument here is what you want to calculate out of this. We want aspects. Now, a very valid question that you may have, and we covered this in the previous class period, is how do I know that this is an option here, and what are the other options? Every time you want to look into that, think of using the help function to get the documentation of this function. So I'm going to ask help terrain. This is what pops up on the side. It's really important to be familiar with the documentation. So here is telling us the arguments. That specific argument, this argument here is basically V. So if we set V equals aspect, that would be equivalent. So it is one or more of these options: slope, aspect, TPI, TRI, Riley, TRI, RMSD, roughness, and flow direction. So this argument can take any of those. We in this class are going to be doing slope, aspect, and flow direction. However, for research, if you ever need to calculate some of these other ones here, you know that this function handles that. So I know that, especially for water movement, you may be interested in TPI, TRI, and some of these variants. So just so you know. All right, so we want the aspect, so we say aspect there, and then it has a unit argument. So unit, I want in this case to be degree. So, and if we look at the documentation, unit can be one of degrees, radians. Yeah, I guess just degrees and radians are the options. And I guess it has to be degrees plural. So this is what we need to do. And then after that, we are just transforming it back to stars and then setting the CRS of that layer. If you want to go ahead, oops, I guess don't forget to add a pipe here after the terrain function, as I forgot. So make sure you add that pipe so it connects through the STS stars. And let's run that. And let's print it. So what I don't expect that you had any issues here. I hope it didn't. But on the print, again, the stars objects do not print as nicely as SF objects, but it does give you a statistical summary of whatever it's in it. In this case, it only has one column called aspect, and it's telling us that the minimum is 0.47, the maximum is 359. So this is in degrees from 0 to 360, just to give you an indication of where is the angle that that pixel is facing. All right, I think I left you all the code here for this, or except for one thing. There are 3 dots here. And I want to ask you, I know I'm being repetitive on this, but I do want you all to be thinking about this. So which geom should we use if I want to show aspect? So remember, aspect is an object that we created here. So what is the geom that I need to ask for to plot aspect? Stars, right? And why is that? Because aspect object is of type stars. If it were SF object, we would use geom SF. So you can change those 3 dots to stars. You can run it and print it. So this is the map of aspect in degrees of this map. You can see the angle that each one of those pixels is facing. And I just want to walk you through a little bit more of this code here. So we're starting ggplot, we're bringing aspect, we're bringing the boundary as well with no fill so we can see through it. We're changing our fill option to Viridis, option E, and I'm giving specific breaks that I want. So I think we've done this before, but where we, on the scale underscore something, function is where you can provide what breaks you want in your legend. So you can see those are the breaks here. And then just changing the title of the legend, and the legend is related to fill. So we need to use labs and then call fill. And I'm just changing that name and using this backward slash n just to break line. And then applying our theme that we created in the first chunks. All right, so next thing here is, so we have elevation, we have slope, and we have aspects. Those are really the most, I would say elevation and slope are probably the most important when you're trying to explain, like relate these properties to yield, for example. I do want to show you one more, which is flow direction. And I think this is going to be quite an interesting one. And I want to go slowly because last semester, I think a lot of students, this was not clear to a lot of students. So I do want to take the time this time and make sure you understand what we're doing. Yeah.
What exactly is the aspect and the degree, but what exactly is that meant for that?
So it's basically, so if you, I mean, we can go into documentation just to make sure, but my previous understanding was that it's the angle. So we would say it would have 0 and go all around to 360. I'm just of that given pixel. I'm just not sure which direction 0 is facing here for this understanding of how it interprets, and we can look into that. Let's see if it tells us. What the map is showing is just that degree. So imagine so if you think about it, the slope map that we have is showing you what is that slope. But just by looking at that, I don't know which way that slope is facing. So it could be this, that, right? I don't know which angle that slope is facing. So aspect is giving you that information, is which direction in an angle measure that slope is facing. Right, so let's say if you come here and you look at a given pixel, let's say all these pixels here have a slope of probably around 2. So I know it has a 2% slope, but in which direction, I don't know. That map doesn't tell me that, right? And then the aspect map is where you learn that. So if you come here on these pixels, we see that these here have an aspect of probably within this range given the color. So let's say it would be like around 202 degrees. So it would be, if you are in that pixel and you know where your 0 degree is, it would be the direction of where that slope is facing. And again, I just don't quite remember which way is your 0 set, if that is if 0 is here and then it does 360, or where that 0 is. But let's see if that documentation here says anything about that. Yeah, I don't think it's really explaining much in the documentation itself. So it says here so we have neighbors equals 4. So we're using 4 neighboring cells. The slope and aspect computed according to this paper. And I guess they are just leaving that reference at the end. So those papers would provide this information of where 0 is. Just from what we know of this field, so 202, so this field, at least these parts are probably facing from west to east, right? So imagine it would be in this direction, these pixels. So if that's the case, then maybe our 0 is set. Let's see. Yeah, I don't know. Maybe it's set to maybe it's set here and then it does 360. I guess maybe that would be yeah, but the idea is that if you're sitting at a pixel, right? And now you know your slope. So let's say you do know that you have a 2% slope on a given pixel, but you don't know yet in which direction that slope happens. Oops. Aspect will tell you that. So, if you were to come here, you would know that this pixel it has in this case, a 22-degree slope. So it would be, I mean, wherever the 0 happens, I think 0 was facing south from what I'm interpreting from the map. So 22 would be going that way, kind of southwest on that specific pixel, right? And each pixel is going to have a different degree. All right, so now flow direction is actually really interesting because it's going to use the information that we provided to understand where would water flow in this field. And I think that's going to be an interesting thing for us to look at, and to also understand how aspect and slope are moving water in this field. And again, water movement in the field are controlled by slope and aspect, and that's probably the reason why these layers can be very important for us to understand the impact on yield, as water movement is also nutrient movement, is also soil movement, and so on. So if you come here on the next chunk, we're going to calculate flow direction and save that into this object called flow dir. The first three steps are the same as what we've done before. I left your 3 dots there, so remove those 3 dots. We're going to call again that same function. So Terra package, so Terra : and then functions called terrain. So the same function to calculate all the different variables. And then the argument here is flow dir, as that is one of our variables that we can choose on this argument for flow direction, right? So it's right there on the documentation. I do want to add a comma here and ask for the unit to be equals to radians. And then after you get at the end of that function, make sure you add a pipe so you connect with the remaining code, which is just transforming that back to stars and then setting the CRS to UTM. So if we run this and we print it, so something I want to call your attention to, and I think, let me just see my code here and see if this is the best time for us to look at that. Yeah, I think that is the best time. So the way that flow direction is calculated and given to us is a little bit different. Perhaps it's not the most intuitive way, and I do want to walk us through how that is done. If you look here on the summary, it has a minimum of 1, a maximum of 128, and the NAs are the same number of NAs we had before. So it's ranging from 1 to 128. So even though we got these units as radians, there is a better way of interpreting these numbers, which if we come here in the documentation of this function.
I'll say I got a minimum of 0.
Me either.
You got
the same here.
You got an error?
No, it ran through fine. It's just I got a minimum of 0, not 1. Just my number's slightly different.
Okay.
You think would that be because our boundaries are different?
It could be. Let me just think about it. So did you change this to radians plural? So unit equals radians?
Yes.
Okay, let me see if I did degrees. How would that impact my results?
That's it. Yeah.
Well, we still have a minimum of 1 and a maximum of 128.
Everything we do on my number is just slightly like including this.
Yeah, so your numbers would probably be a little bit off. In this case, so maybe we can wait until we make a plot and then you can tell me what you see on your side.
Did you have any?
So here in this, so up until now, you could be off a little, and that is expected. In this case of flow direction, I guess until we plot it, I'm not sure, because so here is explaining to us how flow direction is being calculated. So just, if we quickly go through this, it says flow direction returns the flow direction of water. That is the direction of the greatest drop in elevation, or the smallest rise if all neighbors are higher. They are encoded as powers of 2. So what happens is what it does, and I'm not sure if in this case 0 is a valid one. Maybe it is if you had I guess if you had like a slope of 0, I think you could get a value of 0 on flow direction. But let's wait until we plot it just to make sure. But what I do want to show you here is, and for us to understand what these values really are, is that, so the cell to the right of the focal, so there is a focal cell, which is X. So that would be the cell you're sitting on. You're standing on that cell. So the algorithm looks for all the neighbors where the cell right next to it to the right is coded as 1, and then the southwest, so the west is coded as 1, southwest is coded as 2, south is 4, I'm sorry, southeast is 2, south is 4, southwest is 8, west is 16, northwest is 32, north 64, and northeast 128. So these are just codes. They really don't mean anything other than being the coding scheme that this is using. So what is happening here is, if you're always facing north as well in this case. So imagine that you're standing on a cell facing north. You look at all of your neighbors, and depending on the aspect and the slope, it will tell you if water is flowing in which of these directions. But instead of telling you the cardinal directions, it's telling that in this numerical way. There's no coding that says 0 here, and that's why I am intrigued and unsure. I think that it could happen maybe on your boundaries. There were some parts of the field that you included that I did not include in my side, where maybe there was a slope of 0, in which case water doesn't move, right? If you think about it, it's just accumulating there. So maybe that's it, but let's wait until we plot it so we can tell if that's the case. All right, so I just wanted to explain to you that again. So again, the focal cell is X, so that's the cell in the middle. You are standing on that cell, and then you're looking for slope and aspect around the cells around you, and then that way you're determining which way water is flowing. So let's say if I'm sitting here and the lowest drop is on my northeast cell, then the cell I'm sitting on is going to be coded as a 128. Let me say that again. So this algorithm is applied to each cell in our raster. So it's going to start on a cell, look at its neighboring cells, and let's say I'm sitting at a given elevation and a given slope and aspect, and the lowest drop from where I am is towards northeast. So this cell I'm sitting on is going to be coded as 128. And it's going to do that for all the cells here. I know this may be a little bit confusing still. Let's go ahead and plot this so we create this visual understanding. And if at that point is still confusing, let me know and we're going to walk through this. All right, so flow direction is also a stars object, right? We can check that here. So we're gonna, please go ahead and change that geom underscore to stars. So geom stars. We're just making the same plot. The other thing I'm changing here is the breaks. So yeah, I think we can just go ahead and plot this and look at it. So this is how mine looks like. And right now, these are not super easy to interpret, I guess, if you're just looking at these as numbers. But one way that we can think about it is if 128 is going northwest, or sorry, northeast, then all these cells are moving northeast. And I guess we kind of had this understanding that many cells would be moving from west to east just based on our elevation map. So this is in accordance with that, but it's just giving us this idea of where water is moving from this field. So what I want to do now that I think is going to help us to understand better, because I think this map is kind of busy. So one thing I want to do, let me tell you first, I want you to be thinking of how can we achieve this, and then I'm going to ask for some help as we code this. So my next plot that I want to develop here is to basically create one separate plot for each one of these classes going, in my case, from 1 to 128. So that's what I want to do, create one different plot. So making this map times 8, where each one of them is going to only show one of these classes. So we really get a better distinction of which cells are going which direction. So we can leave the ggplot empty at this level. Let's add a plus. We're going to use...
Professor,
Yes.
what did you change in the previous chunk? Because I'm getting an error.
I just added stars here.
Okay. Thank you.
Yeah.
Thank you.
All right, so coming back here, again, the data is going to be flowed there. I do want to make a quick change on the go. So this change I want to make is not going to be reflected in FlowDir dataset, but it's just going to happen on the go, which I wanted. So right now, if we print FlowDir, we get a statistical summary of that column FlowDir, and that's because it's been interpreted as numerical. I do want to treat this as a factor. So right here on the fly, so right after FlowDir, I just want to add a pipe, and I want to pull a mutate and say FlowDir equals to factor FlowDir, just so it's going to be easy for us to plot it. So basically, the data that we're going to be using here is this result here. It's not FlowDir only, it's FlowDir being piped into transforming that column FlowDir into factor. All right, so once you get, so we can go ahead and just run this so we see what happens. So because now it's being interpreted as 0, and I think this would also be a good place for you to look. Now we transform them to 0, and you can see that all the unique values here are the ones from this matrix, at least on my side. And then I have not a number, which are the values where there were NAs, which was, because remember, this is a raster file, so it is a continuous grid, right? So we have cells covering the whole bounding box of this layer, and not just for the field. Those cells outside of the field we've cropped, and so that turns them into NAs or NANs. Now, this case here would be if you had zeros on your side, you would probably have a category here for 0, right? Let me ask this: does anyone here? Is anyone seeing what I'm seeing? Or in other words, does anyone here did not get zeros? Slightly different.
Like we're using NA and not just NA and your background.
Interesting. Let me see. Is that the same for you as well? I mean, are you the same as Doug is saying?
Yeah, I have 0 and
Let me just take a look. Because I mean, depending on what it is, it may just be okay. Nice. Okay, so you have zeros there. Okay. Yeah, good. So do you guys also have all the like visual is with the gray instead of the pink, you have the gray and you have a 0? Okay, it may be a difference in some package version. So if you're seeing what I'm seeing, that's fine. If you're seeing what other students here are seeing are, instead of having the pink, they're seeing just like a gray pixel, and it's, instead of being called NAN, is being called NA, and they also have a 0, which I don't. I don't think that should impact what we're trying to do here. So if that's the case for you, we're just gonna keep moving, and we'll see how it turns out at the end. If our interpretation of the map changes, then I will adjust on the go here. But if not, then that difference will not make a difference in our interpretation. That should be fine then. But yeah, I think that's probably a difference in package version. Probably my version is older than yours and I did not update mine. That's what could probably be happening here. All right, so let's just keep doing this. I do want to bring the boundary. So as you recall, stars objects, when we plot them in ggplot, it tries to stretch the coordinate system here to show you the most data instead of just following a fixed coordinate system, which would be what we would expect to see in a map. So when we bring geom_sf, then it fixes that for us. So let's add a plus here to geom_sf. I want to bring the boundary. We need to say data equals to the object name is boundary_w. And I just want to ask fill equals NA so we can see through. All right. So now that geom_sf is setting the coordinate system to, or the coordinates of this plot or map to be in a geospatial way. So now it looks like our field. Let me see, I have a change here that I'm changing the scale. I guess I don't remember why I decided to do this, but let's just go ahead and do it. Just see if that changes anything. So I'm changing to scale_fill_discrete. Let's see if that has any impact. I don't think it did. So I don't remember why I was doing this in my code, but that's fine. In your side, did this change anything, the way the map looks? No, okay. Yeah, so I don't quite remember why I made that change, but anyways, I guess the other thing I want to do here is change the label of the legend. So flow there. Let me ask again. We talked about this before, but let me ask again. Maybe someone online, what is the function that we need to use here to change the label of this legend? Let's see.
Labs.
Yes, that's it. Is that Rolando?
Yes, sir.
Awesome. Yes, Rolando, that's right. So we use labs, right? So we use the function labs to change title, subtitle, and then any legend that we assign a aesthetics to it. In this case, even though it is not explicit, but geom_stars will always change the aesthetics fill. So that's how we know that this is fill. So we would come here and do fill equals to, I want to call this flow there dot, just to be shorter. So this is what we're changing. I want to come here and apply our theme. So at a plus, we created this object called mytheme_map that has a whole bunch of options that we were changing. So please go ahead and do that. All right, so now comes a little bit of a different part, and I want to see if anyone can help me here to do it. So right now we have all these classes, right? 1 through 128, all being shown in the same map. For it to be easier for us to visualize, I want to actually have a different map where each one of them is only going to contain one of these classes. What do we need here? What function would we use if we want to take one variable, one column, and create different plots for different levels of that column? Say that again. Okay, ggArrange, that, I mean, it could be, but that would be like a different approach. There is a simpler way of doing that here. So every time we're thinking of, I want to make a different plot. In this case, our plot is a map. So I want to make a different map for different levels under a column. So our column here is flow there. I want to make a map for each one of its levels, which are here shown as different colors. If you're thinking of ggplot, you would need to use some type of facet function, right? So in this case, I want to propose we use facet wrap. So if you go ahead and start typing, we're going to use facet wrap. The way the facet wrap works is you just give a tilde and say which column is the variable that you're trying to facet. In our case, that is just flow dir. That's the name of that column. If you run that now, this is what you should be seeing. So one plot for each one of those directions, where the direction now is showing on the, I guess, the title of that facet. Right? And then because now we have the title of that facet, or we know what is being plotted because that level is showing on top on the name of that facet, we really don't need this legend anymore. So if I want to just remove the legend altogether, we can come here at a plus. We're gonna call the function theme. So theme, again, if you come here and hit tab, there's gonna be a lot of arguments you can change about this plot. So anytime you're trying to change something that is not related to a given variable, but it's just like the way that this plot looks, it will most likely be inside the theme function. So here there is an argument called legend.position. I think we played a little bit with this argument in the past, that it takes either two numbers to place the legend in a given place of this plot, but it also takes different characters or strings. So it could be, right now, the legend is on the right-hand side. So that would be legend position equals to right. I could move it to the left, top, bottom, using those words. And if I just don't want a legend at all, I just come here and say none. So the position is none, which understands to simply remove it. All right, so this is what I see now. For those that got 0, Ujwal, did you get 0? Okay, let me come to you because you're the closest here so I can see what you're seeing. But for those that got 0, you may have one of these facets being the direction 0. I just want to understand how that looks on your side since I don't have it. Okay, so there's some cells. That is very interesting. And I'm not sure. Okay.
That's not correct.
Are you getting 0? Yeah. Okay. All right. All right. So I just checked the students here in Athens, and they do have an extra 0. Do you still get nine plots, or do you get 10? 10. Okay, so you just have an extra one here for 0. I don't think that's gonna, I mean, it's what that did is change the color here, but I don't think it changed the interpretation of the map, which is important for us here. So at this point, what I want you to do is, again, let's just cover this again, right? So if I go to a cell, I'm sitting on a cell. I look at the slope. I mean, what flow direction is doing is looking at both the slope and the aspect of the map and telling you which direction, according to 1, 2, 4, 16, and so on, water is moving from, right? So if I am on X, if I am on this pixel, and I have water in this pixel, where does that water move to? And then it's using these, so this, assuming you're facing north, so 64 here is north, and you're sitting on X, it's telling you which direction water is gonna flow from the pixel you're on and to which pixel of the neighboring ones. And right now, I think this way is easier for us to look at that, because then we can really understand like which one of these pixels or in which direction water is moving from and to when we look at the different classes here. So I have quiz here that are two very simple questions. And so the first one is I'm asking you, looking at these plots, and if you have a zero, that's not going to change your interpretation. Which one of these classes is water moving, which one of these classes you think has the most pixels classified under that class, right? So based on the map above, which of the panels 1 through 128 appears to have the most data points? So you can ignore the not a number or NA, you can ignore the zero, just look into the 1 through 128. Which one of these panels you think has the most data points? And then the second question here is whatever you answer above, translate that number into a cardinal direction. So here you're going to say a given number. I'm going to make up a number. Let's say that you say here that it was, I'm going to create a new direction here. Let's say you tell me that it was 300. Let's say we had a class here that was 300. You tell me that this was 300. Then I want you to come here to the documentation of this terrain function, go into this part and interpret what is that direction that you're telling me has the most data points. Remember, the way that that's determined is if you are here in the middle, sitting on a pixel, then 64 is north, 4 is south, and then all the other, so 16 is west, 1 is east, and so on. If all you have to remember is you're facing north and you're sitting on X, that should be enough for you to tell me what is the cardinal direction, and I give you here those options for you to translate the number that you identify here into a direction. Okay, so this is a quiz. It's a very simple quiz. I'm going to give you 5 minutes, and I think that's going to be more than what you need, really. So once you answer these questions, send me your answers to my email, lmbastos@uga.edu. And this will also serve as your attendance for today.
Professor, can you quickly go back to the code, to the previous chunk? Not the previous, this chunk right here.
Mm-hmm.
Thank you.
Just set a timer here as well.
Question like for, I think I missed it earlier whenever you pulled it up, but what tab did you go to over there on the right to find that code or those codes?
Yeah, so I asked for the help, right? I use the help function of the function terrain, which is what we're using. And then that's gonna pop up on the help tab here on your bottom right-hand side.
Okay, thank you.
Yeah.
Help terrain tab.
Yeah, so if you type help terrain, so you're going to ask for the documentation, the function terrain, and then that's going to pop into the help tab here on the right-hand side, on the bottom side. And then if you scroll down, it's going to show you the documentation of that function. It's going to be a part where it gives you these directions here. And I can leave them up here on my side as well in case you all want to see. And again, the key here to understand is that you're facing north and you're sitting on X. Right, we are on the last minute here, so make sure to wrap up. All right, time is up. I think I may be missing one or two of you. Please make sure to submit your answer here on the next minute. I think this is also a good quick stopping point. I will give you 5 minutes for you to take a break, and then we'll continue and finish this exercise here after that. So let me set our timer again for 5 minutes, and then we'll come back to wrap things up. All right, so just to say that again, if you need a break, if you need a water or a restroom break, as we have 2 hours of class today, feel free to take that.
So, hey, Dr. Bastos.
Yeah.
I have a questions about my R here. I think this week something weird happened. You know, like the tab on the top of the screen that shows like the project and like the buttons to save. This one is not showing it. And I try like many times go to the view panes and try to edit, but I can't. I don't know what's the name.
So what
You know how to?
can you tell me again what is it that you're not seeing?
I can't see the tab on the top of the screen that shows like the project and like the save button.
Oh, so this one
This
here?
one, yeah. Yeah,
Huh,
this one.
interesting.
Yeah.
Let's see, where could that be? Always show temp on. That's that. Oh, I'm looking in Safari. Sorry. All right, now in the right place. Toolbar. Okay, so I think that's called a toolbar. So if you come on view, I have this option that says show toolbar.
Oh, yeah, it is. I was looking for the panes and I spent like 20 minutes trying to find it and I was on the wrong side, wrong place.
Yeah,
Thank
sometimes
you.
things are a little bit confusing as far as what they are and what we expect. But yeah, I think normally when it comes down to like these types of things, that was a good guess as well. You know, if none of these options would have worked, I would have looked into Paint as well. But yeah,
Thank you. It's working out.
yeah, awesome. No worries. Okay, let me pull up my timer here so we keep track of that. Yeah, so the midterm is going to be next Wednesday. Yeah, so I want to give you all 2 hours to complete it, even though I think you may not need full 2 hours, but
Do you have that on your paper? Next.
next Friday.
The Friday.
So you mean like on the same week of the midterm? Yeah.
Is it possible?
Yeah, I'll be here. Yeah.
But if I can't make it, how about we go on the 10th?
Okay. Yeah, so if anyone has a conflict for so let me just say that again. Well, let me wait until the timer because if someone is taking a break, I want to respect that and I want everyone to hear this. Yeah. But so in your case, you're saying you're going to be gone on Wednesday.
And I would just be on Friday.
Okay, but
I'll be here for the midterm.
okay, you'll be here for the midterm.
Yes.
Got it. Yeah.
Just that.
Mhm. Yeah, I do. So is that something that you think would be useful?
I don't know because I lost one of my boards.
Okay.
But
Yeah. No, I was doing that more frequently last year. But I guess I didn't really know students were actually using it. So this year I have not done that. But yeah, I mean I was planning to.
because I lost one, then I went to find if you posted.
Mhm.
And I
Yeah, I'll post those so you have access to it. Yeah. No, that's no worries at all. All right, so let's continue here. So Doug was asking about the midterm. I just wanna, and that's something I had on my list to tell today. So we can talk about that now. The midterm is going to be next Wednesday. It's going to be on your own campus location. It has to be in person, so there's not going to be a remote option because it's going to be on paper and it's going to be printed and handed to you. So you have to go to your campus location, in-person location, to take the exam. You're going to have 2 hours. to complete it. So that's why it's going to be next Wednesday. You will only need really just a pen to answer. You don't need a computer. Yeah, I guess, we're going to have many questions and they're going to have different weights depending on how hard the question is or what I'm asking, how many sub options you have within a question. It's going to be related to what we did in the software side and also on the paper side that you were asked to read. Again, my goal here is not to be tricky. I'm not trying to make something difficult that we never talked about. What I'm going to ask you are things that we talked about a lot, that I'm repeating every class. I'm asking you to help me with when we're coding, things of that sort. For you to get ready for it, I would say, read the papers, read the quizzes, read the assignments, especially to pay attention to what I'm asking you in those quizzes and assignments, as that would be helpful as well for some of the questions. I know that I'm lacking here on giving you feedback in your grades. I want to work on that this week and give it so you can know what is going on, if you miss points, why did you miss points? And so we know the correct answer. I think for the most part, we've been talking about the correct answers after the fact, but I have not given you that grade yet, so you can see it. So I'll work on that this week. And yeah, so there's going to be questions related to the theory, the content, like some of the things we've been doing, some of the decisions we've been making here. That's going to be part of it. I'll also include some coding questions. So I'm not going to ask you to develop code from memory. I will give you partially filled code and say, fill in the blanks. And then you're going to have to know, what is it that you need? What geom do you need? Is it scale or fill? Is it an SF or is it a CSV or an SF? And some of those concepts that we've been talking a lot about in classes, things related to that. So I'll give you a partially filled code, and you're going to have to complete that code based on the context that you're given, right? So the code itself is going to have in it the context of the code that I'm giving you is going to be enough for you to understand what you need to fill in the blank. All right. So let's just keep going here. I left you the code for plotting it all together. Just a refresher here. Whenever we create a ggplot and we assign that ggplot to an object, which is what we've been doing up until now, we can then combine those plots using the plus. And this plus here is not coming from ggplot2 package, it's coming from Patchwork. Every time that you want to combine different plots and maps into one, I would highly recommend you look into the vignette of this package called Patchwork, because there are many ways of doing this. It's very customizable and really good to do that in R. In our case, we're just combining all them. So if you run that piece of code, it's just combining them into 2 rows and 2 columns. And right here, at least on my side, it does not look the most intuitive or the best just because they're overlapping. But if you run the ggsave that comes right after it, we're going to be exporting this to file, which if you then go to your files, go to the main folder, go on output, you should see this terrain.png right there. And there, I guess it looks better. So we can really see how this would be on file. So we have all of our primary variable, elevation, and our secondary variables, slope, aspect, and flow direction, all together in the same plot. All right, so the next step here is, so we wrangle elevation, we interpolated elevation, and then with the interpolated elevation data, we calculated secondary variables. So now my goal is to take all these 4 or 3 layers, because we're not extracting flow direction itself. But taking all the other 3 layers, elevation, slope, and aspect, first, my goal here is to change them from raster to vector. The reason for that, I mean, we could make a decision here if we wanted to keep working with them as raster or as vector. We've made this decision before when we were working with the EO data. If you remember, EO data, we did interpolate that as well, but in the end, we transformed that to vector because it's going to be easier for us to visually see this data as a data frame, right? So because of raster, you really don't have a data frame, you just have values in cells. By transforming from raster to vector, instead of cells, we have now polygons. Each raster cell becomes a polygon, and each polygon can have any number of column of data associated with them through different columns. So that's what we're going to be doing here. For us to do that, the way that it works, so we're going to do that first for elevation. I want to show you how that would be. So LF_V, the V stands for vector. So we're going to transform our elevation from raster to vector right here. So if we give it the assignment symbol, we start off with our object that has elevation in raster, which is called IDWPred. That's the one we've been using above. Again, I'm just going to print IDWPred below. It is a stars object, so it is a raster geospatial file type. For us to transform this to vector, there's a couple different ways. I want to show you one of them. So let's add a pipe and let's call the function called st_s_sf. So this function here is whenever we want to transform something into SF. We've used this function before when we had stars. We transformed stars to SPAT-RAST to calculate the slope and aspect. And then we transform it back to stars. In that case, we use st as stars. In this case, I'm taking a stars and transforming to SF. So the function is st_s_sf. We have to change a couple of arguments here. So we have this argument called s_points. I want to say equals to false. The default is true, which if it is true, it returns you the centroid of the cell as a point. I don't want that. I want polygons for each one of the raster cells. So s_points equals to false. And then it has this other argument called merge. I want to say merge equals to false. The default is equals to true. And in that case, it basically merges all of the cells into one. I don't want that. If you run this and you print, notice that now LF_V, which is the product of what we did, is a simple feature collection. So it is an SF object with two fields. Those fields are var1pred, var1var. I really only want to keep var1pred as that is our, in this case, elevation, right? So the incoming data is elevation. So var1pred is elevation. I want to only keep that and rename on the fly. If I want to select a column and rename it, we can do that with the function select. We want to make sure it comes from dplyr package. So dplyr : select. And then I want to say elev_m equals to var1.pred. So var1.pred is the current name. And I'm saying here elev_meter is what I want to rename this while also selecting it. So if you run that and you print it, this is what it should be seen. Right, so just to make sure, we have here again the number of cells of this grid. In my case, is 4,046. In your case, it should be something similar, although it would be probably slightly different because this is based on the boundary. And then also we see that the CRS is projected is NAD83 with UTM zone 16 north because it's carrying over from the IDWPred object. All right, now the next one is we're going to do the same thing, but a couple of changes. So really, I guess we can come up here back on the elevation. We can just copy starting at IDWPred, copy all that, and paste here. Don't forget to add the assignment and just paste it. We have to change a couple things here. So I copied above from the LFPred, but we have to adapt this to work for slope. First off, the object coming in should be different, right? IDWPred only has elevation. The object that has a slope that we created is called slope. So we need to change this. Data coming in should be slope. And if we just print slope by itself, we see that it has a column called PCT. And I really, what I want to do here is rename this column. I want to select PCT and rename it. So then what we do here within the select, you can type slope equals to PCT. So we are selecting the PCT and renaming to slope on the same function. If we run that, again, if you copied it, make sure that you copy the correct one, right? You should have copied the slope data set coming in. So we changed the data set coming in and also the select function. The STSSF remain the same. Again, you can notice that we have less data points on the slope than we did for the elevation. That is because of all those NAs near the field boundary that we had points there for elevation, but it could not calculate slope or aspect because it did not have all neighboring cells. All right, the next one here is going to be for aspect. So the data, I left you all the code. We just have to change the 3 dots. So the data set that we created above that has the S, that is a stars object for aspect, is called aspect. If you were to go back to the code, you would find it. So aspect is a stars object. We're transforming that to a Ceph, so to a vector type, and then selecting this column called values, or actually, I guess it's not called values. On my side, is already called aspect. So if I run this, I think it will give me an error. It would say could not find the values column. Yeah. So if you just leave select aspect, that is enough. And then lastly, the flow direction. I left you the code there already. The only difference is the data set coming in, we have to change. Again, that is just called flow dir. So change that. And let's see, if I just print flow dir here, the variable is already called flow dir. So we don't have to, again, rename it. We can just select it. So make sure you delete the equal values from your select. I guess on the previous version of the package, you used to give that output as values, and that's why I had the code in this way. All right, so what we just did was take elevation, slope, aspect, and flow direction that were rasters, and we transformed them to vector, to SF. So from raster to vector, from stars to SF, right? So now my goal is so these 4 pieces of information are on different objects, right? So if we just go back here, we save the flow dir here, we save the aspect there, and so on. I want to bring them all into the same object where each one of those variables, elevation, slope, aspect, and flow direction, are going to be a different column in a shared data set, okay? So that's what we're going to do next here, and we're going to assign the result of that to this object called terrain_v. So this object is going to have all the terrain variables into one object, one data frame, instead of separated. So let's start that here, give it the assignment symbol. We start off with elevation under elev_v. Remember, these objects that we're going to be joining here are the vector versions that we just created above. So elevation is under elev_v object. If we just run that, it is a simple feature with 4,046 rows in my case. Give it a pipe. We're going to first merge or join the slope data set with elevation. Because both of these objects are geospatial, they are SF objects, we're going to use a function called st_join. If these data frames were not geospatial, or maybe even if just one of them were not geospatial, we would have used left join, which is a function from dplyr we've used before to do wrangling. In this case here, It's going to look into the overlap in space between both layers to join them using that geospatial information rather than using a common column, which is what the left join does. So the first argument here is what is the data set that we want to join. That is called slope underscore v. We do want to change a couple of arguments in here. The first one is I want to change the join type. So I want to say join is an argument equals to the function that is called st equals. You don't have to have the parentheses on this function. It's just a name like that. I give it a comma and I want to say left equals true. So it does a left join. What is a left join? A left join is that it looks into the data set on the left and then brings the data set on the right and joins this way instead of looking on the right and bringing the left. This makes a difference here and I'll show you why in a second. So let's just run this first. And I just want to print terrain V below here so we can inspect how that looks like. Every time you do a join, that being a geospatial join like we're doing, that being a left join, which is not on geospatial objects, always double check the resulting number of rows and check if that makes sense. Sometimes weird things happen with joins because of the way the data is formatted, and you may end up with 2 times the number of rows you intended. Always check that. So in my case here, LFV is the one on the left, right? So LFV in my case has 4,046 rows. I'm bringing slope V into it. So my resulting data set the terrain V should have 4,046 rows as well, which if I print terrain V, it does have. Now, look what, yes.
What was the reason for doing the join in and then st equals?
So the join, so if we ask for help on st join, so we get the documentation of that function and we just take a look at it. And we look at the arguments. So it says here, geometry predicate function with the same profile as st intersects. So st intersects is the function that it uses by default. And for our case, that was not giving me the correct join. On my side, I troubleshooted this before it got to you guys, so you never saw that troubleshoot happening. But if you do if you do not change the join here, if you do not, oops, sorry. If I don't specify this, it's gonna do a join equals to st intersects, which for the most part works. For our purpose, it did not. So imagine that all of our interpolation values are based on a grid, and that grid remained the same for all these layers. So I wish that it would, so what st equals does is it looks into all these layers that have already been interpolated to the same grid. So they do align up when we stack them, if you think of that way. And so I do want it to see, so the polygons of a given pixel across different layers are on the same place. They are equal in space. So that's what st equals is doing for us. And for this purpose, I found that st equals was the best one. If for some reason you don't specify st equals, you just let the default be used and it comes back with a number. Well, I guess, we can try to at least see if that impacts the number of rows. So, well, I guess I can just leave like that, which deactivates st equals. Yeah, so this is a great example. So the default join, I believe, is st intersects. And you can see here that is giving me back 33,000 rows instead of my 4,000. So it's really creating more points and it's not very clear why. So when I was playing around with this and troubleshooting it, I noticed that if I use st equals, it fixes that. On the documentation here of that st join, if you click on so it has the arguments, subtitle, it has join in there. If you click on this st intersects, no, sorry, that's actually not it. So here it says see details. So if you go on the details, it's gonna list here for you all different types of joins that you can do. And some joins may be the best option for a given application. And you can really see what they mean by looking into these functions specifically. We're not going to do that here, but there are all these different types of joins as options of that argument. In our case, st equals is what gives what we want, which in our case, I know what we want because I have all these cells in a lab V, and a lab V has 4,046 rows. I want the result of this join to have the same rows as LFV, as that is the starting data set. We're just appending to it. So that's how I troubleshooted this. Yeah, so LFV and terrain V should have the same number of rows. And that's, again, that's why it's important for you to check the product of that join, which in our case, we're assigning that to terrain V, and see if that number of rows is matching what you would expect. In our case, we would expect it to be the same as 11V. Did that help?
Yes, sir. Thank you.
Awesome. All right, great questions, great discussion. Okay, so our goal now is to, so if you inspect terrain V, well, let me make sure I rerun it with the join equals st equals. I have 4,046 rows, and now I have a column for LF, a column for slope. Another change I want to show you here is what happens if I do left equals false. If I do left equals false, it is doing a right join. So it's the opposite of a left join. So I'm saying left join, false, meaning it's doing a right join. What is a right join? In this case here, a left V is the first one we give. That is considered the left data set. Slope is the second one I give. That's considered the right data set. So left, right is a slope. If I'm doing a left join, I'm looking on the data set on the left, which is 11, and I'm bringing slope on it. What happens then is, in this case, slope and aspect do not have the same number of rows, if you remember, because it had all those NAs. If I do left equals false, which does a right join, it means I'm bringing slope, which has fewer rows, and then bringing elevation, which has more rows. In that case, if I do a right join, then terrain V is going to have the same number of rows as slope, which means that all the elevation data points I did have around the boundary are going to be dropped, which at least my decision is not to do that. But so if I do say left equals false, in which case it makes a right join, in which case it brings slope as the main data set and joins elevation, terrain V should have the same number of rows as slope, which again is not what I want. So if you look at this right now, I don't have any NAs on slope or in elevation, which is what you would expect. When I had left equals true, so it is doing a left join where elevation is on the left, is bringing slope on it, then any cell that was present on elevation and it was not present on slope becomes NA, as you can see here. So that's the difference between doing a left join or a right join, is which data set is used as the frame to bring the other one. So that's why we change the join type and also make a left join by saying left equals true. All right, so really what we're going to be doing next is just, I want to ask you to just copy, starting at the pipe, just copy this. And then right after that parentheses, paste it. Because now we're going to bring aspect, the name of that. So we have to change the data set coming in. It's called aspect underscore V. If you run that and you print terrain V, it should again have the same number of rows. Again, we're not changing number of rows, right? We're just adding columns. So it should still have the same number of rows as 11 underscore V. It should only now have another column, which we see down here. So elevation, slope, and aspect. And lastly, I think we do include flow direction here. We're just not going to use it when we do the management zones. But so just to keep with what the script has in it, so let's just paste that again and then change slope V to flow dir V. So as you are copying and pasting this code and adapting it, make sure that you have the pipes, make sure that you're changing the data set on each one of those. So we start with the levy. The first ST join is on slope V, second ST join is on aspect V, and last ST join is on flow dir V. Make sure you change those. Once you do all that, make sure you run that piece of code so it reflects on your outcome. If you just print terrain V, make sure that your number of rows is the same as your number of rows for a levy, so you can print both and compare. Terrain V should have the same number of rows as a levy. And then if we get a summary, which I left you the code there, so just plugging that into a summary function, we just see here a statistical summary for elevation, for slope, for aspect, and flow direction. We have different numbers of NAs, and that is because of that difference of the cells around the borders. All right, so last thing we're going to do here is to export this, because again, remember the reason why we're doing this is elevation as the primary variable, and the secondary variables that we get from it are important variables for us to create management zones. And that is the final goal we're looking into. That's the vision here. So because we need to have access to what we just created, we need to export this to file. To do that, we're going to use the function write_sf. We give here the object that we're exporting, that is terrain_v. If you just give a comma, break code, I want to open and close quotation marks. I want to export this to the data folder. So .. to get outside of code, hit tab, go inside data, and let's give it a name. I want to call this terrain_v. And here we also give the extension. So we need to say .geojson. Lastly, here inside write_sf, still, we need to change that argument so it does not append in case you run this code twice. So we need to say delete_dsn equals to true. Make sure you run it, and then you can come on your files tab, on your data folder. You should see now that terrain_v.geojson there. It's important that you do this because again, when we finish analyzing all these layers, we will bring them back into a different script. So that's why we are exporting them. All right, so a quick summary here and what's coming up. So today we have imported the point vector elevation data. Remember, that was a point vector data. We first had to interpolate that vector data into raster. So we have a continuous layer of elevation. We use that raster elevation object to then compute secondary variables of slope, aspect, and flow direction. There were other options here that we could have calculated. I did not, but if you want to do that for your research, I showed you how to find that. And then at last, we transformed them from raster to vector and joined it all into one object and exported it. Okay, so if now we think about it, so we brought in EO data, we processed all that, we got the spatial temporal classes, so we understand how yield is changing. Now we brought elevation data, we processed that, created secondary variables, exported that to file. The next step is going to be to do a similar approach, but with soil EC data, electroconductivity. We're going to have first a quick lecture on this so we understand what it is and why we're using this layer and how it is collected. And then we're going to get into the coding exercise of processing that layer and also exporting to file. At that point, we're going to have all the layers we need to create management zones, which is then the next step after that. And then we're going to validate those zones using all these layers again. So this is what I had for today as far as exercise. I want to open up quickly for questions, but there's going to be something else after this that we're going to do still today. So any questions about this? If you have questions about the exam, we can hold that for maybe Friday. That is probably going to be a better time to talk about that. But any questions about this exercise?
The one quiz that you gave earlier today, What would be the answer to that? Can you tell me that?
Yeah, thanks, Kumar. So let me come back here to that. So regardless if you had the zeros or not, I think all of you were still getting the same interpretation of the remaining sides. So really the one here that has the most data points is the direction 1. I did not look at all the answers. If you answer 1 or 128, I would accept, because 128 also seems like it has a lot. If we look numerically, if we do a summary, a group by and a tally, you would see 1 is more, but I was asking you to assess visually. So if you assess visually and you told me either 1 or 128, then you got that correct. And if you use that matrix that we were looking at the help of this function, so help terrain, wait. So the matrix was this. So 1 here is east, right? So the direction 1 is east. Direction 128 here would be northeast, if you answer any of those. So the way that we would think about it, which it makes sense based on the elevation map of this field. If you recall, elevation had a gradient from west being highest to east being lowest. So it makes sense that most of the pixels are running, or water is flowing east, right? In this case, from west to east. So that makes sense here. And then the other majority is flowing northeast. So in the east direction is the main movement of water in this field, which again matches our map of elevation. If you look, I'm going to pull up here the map that we just created. If we look on elevation, the highest points are on the west, the lowest points are on the east. So this makes sense. All right, any other questions? So I had another quiz, which is going to be a little bit more involved. And we do have here 25 minutes. I think that should be enough. I gave last semester 15 minutes for people to complete. Normally, I would give this quiz in another class. I do want to give that today because that can put you already in the mindset of some of the things you should be thinking for the exam coming up. So maybe let's take this other more involved quiz today, and then we can talk about it on Friday if you have questions about it, and we can discuss as a prep for the midterm. So this quiz here, I just uploaded that to our GitHub repo this morning. So you would need to go ahead and either pull from the repo or download that again. It's going to be inside of the folder called 07 quiz. There is a quiz-4 subfolder in there, and there is a QMD for that quiz. So please go ahead and pull that or download from the repo. Once you download this, I want you to copy this script and paste inside the code folder of your 07. Well, let me make sure here I'm telling you the right place. Let me just open another tab. Yeah, so after you download it, I want you to copy this questions.qmd and paste that into the code folder of your 07 EO monitor data. The reason for that is that the quiz brings in a data set, and that data set is in that project. So if you just double click on that, the path is not going to work. On that script, the path is not going to work. You have to move this inside the code folder of the 07 EO monitor project. And if you wish, you can launch the 07 EO monitor project as well, which is what I'm going to do on my side. So once you download from GitHub, copy and paste that quiz for QMD from GitHub to the code folder of your 07 monitor. You can go ahead and launch 07 monitor, go under code, and then launch that questions QMD so you can see it. I have 9 questions for you. So some quick instructions is make sure you change your name on the author list of the YAML where it says your full name, change your name there. I left you here. So I'm not asking you to really do any coding. I'm just doing the coding already to bring in a data set. So if you run that chunk, it's just going to read our 07 yield 17 data set. And then it is, if you run the next chunk, is just printing the data set for us. I'm using this function here called cable, which comes from a package knitr, because when you render this, which you will send me the render version, if you render this, the table appears in a better way on the render version. So I'm just rendering here so you can see. I want to open that on my browser. So when you render it, it's going to show you the first 5 observations. And then I'm asking you here questions related to that. So number 1 is this file geospatial? How do you know? What function would you use to transform it into an SF object? Once we transform into SF, is it vector or raster? And then I want you for each one of these options here to tell me if you think they're vector or raster. Number 5 is if we wanted to apply the speed and yield filters on this data, which column names would we need to use for that? So what I'm asking you here is to come look at the current column names and tell me what are the column names we need to apply filter or to apply the speed and yield filters as we did in class. This here is asking if you remember the EPSG value for WGS84 and tell me what is the unit of that CRS. Then I'm asking you if we compare WGS84 or NAD83 UTM, which one of those do we need to perform distance-based operations and why? I'm asking you here to write the code below that we would need for plotting the yield data set above, assuming it was an SF object and that we wanted to call the points according to the column yield pounds per acre. This is just 2 lines of code that I want you to write. You don't have to run it. You just have to write the code as if you would to make this plot. And then I'm telling you that I share with you a data set and I'm asking you to do a project setup. So I'm asking you to tell me which folder would you create, which subfolders would you create, which files would you move into different folders to get started with a given project. We've done this a lot of times. I hope that you already have a good understanding of this. So again, there's one question that asks about coding. You don't have to actually run the code. You just have to write it. And you can do that on the QMD one, right? So in the end, you're gonna, your answer is gonna be right below these questions on the QMD. I just want you then to render them and send your render HTML to me. And then I'm asking you here that once you render to add your name also to add your name to the file name before you share with me. One quick question here, or one quick point is if after you render, if your answer here, you're writing something and then you render and then it appears together like that, remember that to break line, you just have to go where you want to break line and give 2 white spaces. That's what breaks line. All right, I'm gonna let you get started. If you have trouble with running this code that I'm giving you to look into to answer some of the questions, let me know. If you have trouble rendering it, let me know. But these are pretty straightforward questions that I don't think will take you a lot of time. And again, this is a quiz. This is not an assignment or an exam. It is gonna be worth as a quiz and fall into that category. Guess I'm gonna stop recording here, but we'll keep going for another 20 minutes.